More than 9 inches of rain fell northwest of Des Moines in a single day, not over a week, not a multi-day accumulation. A single 24-hour window dropped enough water on central Iowa to overwhelm drainage systems, flood roads, and force emergency responses across communities that had no time to prepare. Suburbs west of Chicago received 4 inches during that same period. A buckled road near Milwaukee shut down a freeway interchange on July 2nd. Motorists sat on an interstate highway while the pavement beneath them had literally warped from days of sustained extreme heat. And all of that happened while the heat dome was still holding. Right now, at this moment, July 3rd, this system is still very much alive over the eastern half of the country. More than 200 million Americans remain under extreme heat alerts. But I am not here today to recap what you already know. I am here to walk you through what comes next. Because the physics of what happens when a heat dome this large and this powerful finally starts to break down, the storms that ride in on the collapse, the way the heat shifts and rebuilds somewhere else, and the atmospheric driver underneath all of it that will shape your weather from here through winter, that is the story. And the version you are hearing from most sources right now is missing chapters 2, 3, and 4 entirely. I am Arthur. This is Sky Space Lab. Wherever you're watching from right now, I want you to stay with me through this forecast, because there are people in this audience who are in the path of something significant over the next 10 days and do not know it yet. Let me give you the roadmap before we get into the data. The next 14 days break into 4 distinct and very different chapters. Knowing which chapter you're in and which one is coming next is everything. Chapter 1 is what is happening right now, today through Sunday, July 6th. The heat dome is still dominant over the east and the south. It is killing people. It is warping infrastructure, and along its northern and western edges storms are already firing. Tonight, tomorrow, and Saturday carry significant severe weather risk for the northern plains, the Midwest, and portions of the mid-Atlantic and northeast. Chapter 2 is the collapse, Sunday evening through Tuesday, July 8th. The dome breaks from the north and the east. A frontal boundary drives south and east. The atmosphere wrings out every molecule of moisture it has been loading under that lid for the past week, and it does it fast. Flash flooding is the primary concern in this chapter, but damaging winds and isolated tornadoes are also in the picture as the boundary organizes. Chapter 3 is the rebuild, July 9th through the 14th. Here is what most coverage is missing entirely. The heat does not die. It relocates to the south and southeast. The Weather Prediction Center described it as a major heat wave settling over the south and southeast next week. At the same time, shortwave troughs continue dropping through the Great Lakes and the northeast. What that means in plain language, you are not trading dangerous weather for safe weather. You are trading one type of dangerous weather for a different type of dangerous weather. Chapter 4 is the long game, and it is the one that matters most for understanding everything that is happening right now. An El Nino event has officially been declared by NOAA, and the latest models from the ECMWF, NOAA's own CFSV2 and IRI Columbia, are projecting it to reach historically extreme strength by fall. That signal is reshaping the entire summer weather pattern over North America, and it is going to continue reshaping it into the winter. Let me start where you are right now. Today, July 3rd, the Storm Prediction Center issued their convective outlook. A slight risk, level 2 out of 5, covers a corridor from the Dakotas through the western Great Lakes. The primary threats are damaging winds and large hail. In portions of the northern plains, where Cape values are running at 3,000 joules per kilogram or higher during peak afternoon heating, discrete supercells are possible this afternoon and evening, before the atmosphere upscales into linear clusters. A tornado cannot be ruled out in this environment, particularly in the zone from western South Dakota into southwestern Minnesota. If you live in those areas, have your shelter plan ready before 3 o'clock this afternoon. The National Weather Service office in Chicago released their hazardous weather outlook at 3:17 this morning. The specific language states damaging wind gusts up to 60 miles per hour are possible across northeastern Illinois and northwestern Indiana tonight. Large hail up to quarter-inch size is in play. A level 2 severe risk is in effect for areas generally along and north of Highway 30 through this evening, with a marginal risk extending south to Interstate 80. The NWS Quad Cities office, issuing at 4:40 this morning and covering areas from Buchanan County in Iowa eastward through Rock Island and Whiteside in Illinois, confirmed that the entire outlook area will be susceptible to rounds of thunderstorms from Friday through at least Saturday night. Almost the entire area sits in at least a slight risk on Friday. Damaging winds are the primary concern. Do you live near the I-80 corridor between Iowa and northeastern Illinois? Drop your city in the comments right now. I want to know who is watching from directly in the path of tonight and tomorrow's activity. Here is what is fueling this. The heat dome has been pumping deep tropical moisture into the northern plains and Great Lakes for the better part of a week. Surface dew points across Iowa, Illinois, Indiana, and Ohio have been running in the lower 70s. To put that in perspective, lower 70 dew points in the lower Midwest are what you expect in August during a humid subtropical air mass intrusion. Having those values in early July, combined with surface temperatures in the low 90s, creates what meteorologists call a highly loaded atmosphere. Every afternoon, the sun heats that moisture-laden air mass, and the atmosphere becomes progressively more unstable. By 3 or 4 in the afternoon, the cap, the warm layer aloft that holds the atmosphere in check, breaks. When it breaks fast. And the storms that erupt out of that cap break are explosive. Fox Weather reported that the ring of fire setup is already spanning a 1,500-mile corridor from the central plains through the Great Lakes and into the northeast. This week's storm activity already confirmed that. Damaging storms brought down trees and power lines across upstate New York and New England earlier this week. By Wednesday, storms in Wisconsin produced a 3.25-inch hailstone confirmed in Fond du Lac. That is larger than a baseball. That is the atmosphere telling you exactly how much energy is available right now. The ring of fire is not a figure of speech. It is a specific physical mechanism, and understanding it helps you know what to expect in the coming days. A heat dome acts as a cap, suppressing storm development over the hottest zone. But along the northern and western edges of that dome, wherever slightly cooler air is undercutting the cap, the suppression lifts and storms develop explosively. They move fast. They can produce supercell tornadoes, baseball-sized hail, and destructive winds in rapid succession before upscaling into large bowing linear systems by evening. The damage mode transitions through the day. Afternoon and early evening, tornadoes and hail are the main risk. Late evening through overnight, damaging straight-line winds dominate. The NWS Chicago office confirmed that general storm motion today is toward the east at 40 miles per hour. These storms move fast. They arrive and depart quickly. That limits warning lead time. Be ready before the storm is on the radar, not after. AccuWeather meteorologist Alex Sosnowski, in a forecast released this morning, used language that I think deserves direct attention. He described the atmosphere as loaded with moisture that will be wrung out as the heat dome collapses and slightly cooler air arrives from the north. That process has already begun in the north-central states. More than 9 inches of rain fell northwest of Des Moines. Suburbs west of Chicago received 4 inches. Those events already happened before the collapse fully arrived. What AccuWeather is telling you now is that this is the beginning, not the end. The AccuWeather local StormMax wind gust for the zone stretching from northern Mississippi and Alabama north through New York and into Vermont and New Hampshire is 85 miles per hour. I want to be very specific about what that number means. It is the maximum wind gust that AccuWeather projects could be produced anywhere within this event zone. Not every location sees 85, but some location in that zone could. At 85 miles per hour, large trees snap, power lines go down, unsecured structures fail, vehicles can be pushed off roads. This is not a threat to observe from your back porch. This is a threat to shelter from. The storm prediction, Center's Day. 2 outlook for tomorrow, Friday the 4th of July, projects an expanded severe weather zone. A concentrated zone of severe storm activity runs from central Nebraska and southeastern South Dakota to central Iowa and northwestern Missouri. A broader zone of isolated to scattered severe weather extends along an 1,800-mile corridor from near Interstate 25 in Colorado and Wyoming east, all the way to the mid-Atlantic beaches and southeastern New England. More than a dozen states could have locally damaging storms on Friday. Let me give you the city-by-city picture for today and the next few days. Sioux Falls, Aberdeen, Rapid City. These are your high-priority locations in South Dakota for storm activity today and Saturday. The northern plains atmosphere is primed for afternoon supercell development. West of Aberdeen, discrete supercells may be able to maintain isolation long enough to rotate. If that happens, tornadoes are possible. By early evening, those individual storms typically merge into a line, and the threat transitions to widespread damaging winds. Fargo, Grand Forks, Bismarck. North Dakota communities are also in the zone for Friday and Saturday. The severe weather risk extends north through the Dakotas and into portions of Minnesota, Des Moines, Iowa City, Cedar Rapids. Already impacted by significant flooding this week, these communities are starting the next wave of storms with saturated ground and stressed drainage systems. Flash flooding risk here over the next 72 hours is significantly elevated above baseline. The WPC's flash flood risk graphic, updated this morning, reflects that concern. Chicago, Rockford, Milwaukee. The NWS Chicago office has been issuing daily hazardous weather outlooks for multiple days in a row now. The extreme heat warning for Chicago expires overnight tonight. By Monday, temperatures drop to the 80s. That is real relief. But getting there requires navigating Friday's storm threat and Saturday's storm threat first. Have your fireworks alternative plan ready. Know where your nearest building shelter is before tonight's show begins: Indianapolis, Columbus, Cincinnati. These communities are in the transition zone where the heat is still significant. Heat index values may reach 100 to 105 degrees today, but severe weather risk is moderate. Watch the forecast guidance from your local NWS office closely tonight and into Saturday. Pittsburgh, Philadelphia, Baltimore, Washington, D.C. You are in the heat right now. The Northeast Heat Dome is still fully in force over your region through today and Friday. Washington, D.C. may not see meaningful heat relief until late Friday night. Saturday brings improvement. But Monday, and I want to flag this specifically, Monday brings an organised severe weather threat. AccuWeather has identified a severe weather zone from near Pittsburgh eastward to Virginia Beach, Virginia, and Greenville, North Carolina for Monday. The local storm max wind gust for Monday's storms in this zone is 80 miles per hour. If you're in Pennsylvania, Maryland, Delaware, New Jersey, or Northern Virginia, Monday is a day to plan your outdoor activities around the storm timeline, not the other way around. The WPC excessive rainfall discussion, released at 11:53 this morning Eastern Time, placed a slight risk of excessive rainfall across portions of the mid-Atlantic on Monday. Northern Virginia, Maryland, Northern Delaware, New Jersey, and the eastern two-thirds of Pennsylvania are specifically named. The marginal risk area for excessive rainfall on Monday spans from Mississippi northeastward to the Atlantic coast, and northward into upstate New York and southern New England. That is 11 to 12 states where flash flood awareness needs to be elevated on Monday and Tuesday. Here is the detail that matters most about the rainfall threat. AccuWeather noted this morning that much of the total rainfall could fall within several hours during each round, leading to flash flooding. The AccuWeather local storm max rainfall for this overall event is 6 inches. 6 inches over 2 to 3 days is manageable in most contexts. 6 inches in 3 hours over saturated ground is catastrophic. Small streams respond to heavy rainfall faster than any warning system can notify you. If you are camped along a small stream or creek this holiday weekend, move. The stream that looks manageable at 9 in the morning can become life-threatening by noon if the right storm cell sits over your drainage basin for an extended period. Have you been hit by flooding already this week? Tell me in the comments, your city and what you're seeing on the ground. I am reading every comment. Now let me take you into the big picture. Because what is happening over the United States right now is not a random event. It is the product of a specific atmospheric configuration that has been building for months, and understanding that configuration is what separates a weather report from a weather forecast. The heat dome that has been parked over the central and eastern United States this week is one of the most anomalous heat events I have tracked in years. The temperature anomaly at the 850 millibar level, roughly a mile above the surface, has been running 10 to 15 degrees Celsius above normal over the Great Lakes, the Northeast, and Ontario, Canada. In operational meteorology, you rarely see that kind of anomaly maintained for multiple days across that large an area. When you do, you know you are not dealing with a normal heat wave. This is a heat siege. The surface data bears this out with stunning clarity. La Crosse, Wisconsin's overnight low temperature on Tuesday was 81 degrees Fahrenheit, tying its all-time warmest overnight temperature on record, a record that goes back to 1872. 154 years of records tied in a single night. Louisville, Kentucky dropped to 79 degrees overnight on Tuesday, a daily record. Rockford, Illinois hit 77 overnight. Topeka, Kansas recorded 79. Dallas fell to only 81 overnight on Monday, tying a daily record set just 2 years ago. These overnight records are the most important and least discussed aspect of this heat event. The body can recover from extreme daytime heat if overnight temperatures drop into the lower 70s or upper 60s. When overnight temperatures stay in the low 80s, there is no recovery window. The cumulative heat stress on the human body builds from day to day. By day 3 or 4 of sustained high overnight temperatures, even healthy adults begin to experience physiological stress from heat. For the elderly, for people without air conditioning, for outdoor workers, this is when heat becomes a genuine emergency. New York City temperatures did not drop below 82 degrees in Central Park on Thursday morning. AccuWeather reported that New York City may record 3 consecutive nights with temperatures not dropping below 80 degrees. According to historical weather records, that has happened only a handful of times in recorded history. Philadelphia and Washington are experiencing heat index values of 105 to 111 degrees Fahrenheit along the N95 corridor. The AccuWeather Heatwave Severity Index is rating the New York City heat event from July 1st through July 4th as a strong heat wave by their formal definition. The National Weather Service, Brian Putnam from the Weather Prediction Center, made a specific point this week that I want you to hear clearly. Paraphrasing his remarks from multiple interviews, the humidity is compounding the effect of the high temperatures dramatically. He specifically named people who are not adequately hydrated and people who do not have access to cooling as facing serious risk. The NWS official guidance on heat is direct and unambiguous. Heat is the deadliest form of weather in the United States, more deadly than hurricanes, more deadly than tornadoes, more deadly than flooding, annually on average. Check on your neighbors, not as a figure of speech. Walk next door, call your elderly relatives. If you know someone living alone without air conditioning in the path of this heat event, act now. Those deaths are preventable. The infrastructure stress is also worth understanding. The road that buckled near Milwaukee on July 2nd, shutting down a freeway, is a physical manifestation of what sustained extreme heat does to the built environment. Asphalt is designed to expand and contract with temperature changes, but it has limits. When surface temperatures stay at or above the design threshold for multiple consecutive days, the material fails. Railroad tracks warp and expand, which is why Amtrak and other rail operators impose speed restrictions during extreme heat events. Electrical transformers run at peak load continuously when air conditioning demand is sustained at maximum levels for days. Water mains crack under thermal ground stress. These are not dramatic news stories. They're quiet failures that accumulate across a region during events like this one. The broader weather pattern driving this event, and the mechanism that explains why the collapse leads to violent storms, is the omega block. An omega block is a persistent high-pressure system flanked by low-pressure troughs on both sides, creating a shape in the jet stream that resembles the Greek letter omega when viewed on an upper-level atmospheric map. The center is the heat dome. The flanking troughs are where the energy is moving. The key characteristic of an omega block is that it resists movement. The high-pressure center holds its position, forcing weather systems around it rather than through it. That is why this heat dome has been in place for so many days. The trough on the western flank of this omega block is particularly energetic. The SPC noted in their Day 4 through 8 outlook that model trends show the upper ridge amplifying less in the west than in previous cycles, which keeps that western trough more active and persistent than a typical early July setup. When the omega block finally breaks down, it tends to do so aggressively. AccuWeather used the phrase potentially violent thunderstorms to describe what develops as the ring of firestorms move toward the center of the shrinking dome. That is not language AccuWeather uses lightly. The combination of explosive instability from the loaded atmosphere, the dynamics of the incoming trough, and the rich moisture field means the storms that develop along this collapse boundary are particularly capable of producing severe weather. The CNN meteorological team noted this week that the central and eastern United States is entering what is climatologically the hottest time of year. Most areas see their climatologically average hottest day in July. Just as this extreme heat dome is arriving, that timing matters. The atmosphere has been primed by weeks of above-normal temperatures building toward the climatological peak. The moisture field is exceptionally deep. The jet stream dynamics are aggressive. This is not a marginal event colliding with a marginally stressed atmosphere. This is an extreme event hitting an already stressed system. Now let me walk you through what comes after the collapse. because this is where the forecast gets complicated and where most coverage stops too early. AccuWeather's long-range team is projecting that the next phase will see the heat dome shift westward and rebuild over the plains in the western United States. The WPC extended forecast discussion, released this morning, uses the phrase major heat wave to settle over the south and southeast next week. Daily heat index values of 105 to 110 degrees are projected from eastern Texas across Mississippi, Alabama, Georgia, and the Carolinas into the mid-Atlantic and southeast coast during the week of July 7th through the 14th. Let me put that in geographic terms. Charleston, South Carolina, Savannah, Georgia, Memphis, Tennessee, Birmingham, Alabama, Mobile, Alabama, Raleigh, North Carolina, Richmond, Virginia. These cities are heading into their most brutal stretch of the summer starting next week. If you are in the southeast and you're telling yourself the heat is almost over, it is not over. It is rebuilding. The WPC's own forecast discussion, citing a surface low pressure system moving through the east in early next week, projects that storms in the northeast and mid-Atlantic will generate excessive rainfall from the lower Mississippi Valley to the northeast on Monday specifically. So the pattern for Monday is simultaneously rebuild heat in the south, active storms in the northeast, and a stalled frontal boundary that could produce repeated rounds of heavy rainfall across the mid-Atlantic coast. That stalled front is what concerns me most in the 10 to 14-day range. When a frontal boundary stalls over a moisture-rich environment, it becomes a training boundary. Individual storm cells develop over it, move along it, and then new cells develop right behind them in the same location. A single location can receive multiple intense rainfall events over several hours. 2 inches in 1 hour, drainage clears, 2 more inches over the next 2 hours. That is when small streams go from normal to flash flood in a very short window. The WPC's local storm max rainfall for this event is 6 inches. In an area with a stalled front and a training storm pattern, 6 inches is not an extreme upper bound. It is a real possibility in a concentrated area. The week of July 7th through 14 for the Great Lakes and Northeast means something different. The SPC day 4 through 8. Convective outlook from Thursday morning explicitly notes that localized severe potential will exist near surface boundaries and any mesoscale convective vortices that are present. Mesoscale convective vortices, I will call them MCVs, are spinning, organized remnants of overnight storm clusters. They can persist for 12 to 18 hours after the parent storm complex dies, and they can trigger new convection, new severe weather, and even isolated tornadoes well after sunrise, well after most people have concluded that last night's storms are over. Indiana, Ohio, Michigan, Western Pennsylvania, upstate New York. All of you in these areas need to stay weather aware through the overnight hours on Sunday, Monday, and Tuesday, even if the afternoon and evening hours appear quiet. Now let me take you to the story that sits underneath all of this. The NOAA Climate Prediction Center issued an El Nino advisory this month. The official language is precise. El Nino conditions are present and expected to strengthen into the Northern Hemisphere winter of 2026 and 27. That is the Climate Prediction Center's formal declaration. El Nino is not coming. It is here, and it is accelerating. Here is where the data gets extraordinary. The IRI Columbia Model Ensemble, one of the gold standards in seasonal climate forecasting, published their June Quick Look this month. The weekly Ninyo 3.4 sea surface temperature anomaly, centered on June 17th, reached positive 1.7 degrees Celsius. Positive 1.5 is the NOAA threshold for moderate El Nino. Positive 2.0 is the threshold for strong. At positive 1.7 in mid-June, this event is already approaching moderate strength, and it is still building. The IRI ensemble of 24 individual model runs shows all 24 projecting continued El Nino conditions throughout the forecast period. 13 of those 24 models project the anomaly reaching positive 2 degrees or higher by the September-October-November period, 13 out of 24 projecting strong or very strong by fall. The IRI summary states explicitly, the ensemble shows a strong and consistent signal for a continuing and intensifying El Nino event, with negligible likelihood of ENSO-neutral or La Nino conditions. Negligible likelihood, not low likelihood, negligible. The models are not hedging on direction, they're converging on a trajectory. The ECMWF extended long-range forecast independently analysed by severe-weather.eu this week, show some ensemble runs projecting anomalies exceeding positive 5 degrees Celsius by the peak period. I want to be genuinely careful here. Positive 5 is historically unprecedented in modern records. The strongest El Niño events on record, 1997 through 98 and 2015 through 2016, peaked around positive 2.5 to 3 degrees. Positive 5 would represent territory that has no modern analogue. Severe-weather.eu's analysis noted that ECMWF, NOAA, and BOM model ensembles are now aligned on what they described as a high-impact trajectory, with several forecasts suggesting this event could become the strongest El Niño in modern history, potentially surpassing the record-breaking event of 1877 and 1878. I repeat, those are projections at seasonal timescales, and seasonal projections carry significant uncertainty. I am not forecasting positive 5. I am telling you what the models are showing, because that information is relevant to your weather planning. NOAA Director Ken Graham said specifically in this month's declaration, and I want to paraphrase this precisely because I think the nuance matters, every El Niño is not the same. Each one is unique with its own imprint on our weather. Advanced monitoring and an improved understanding of El Niño patterns allow the National Weather Service to better predict and better prepare the public for what is to come. The director of NOAA's National Weather Service is telling you directly, the warning systems are more capable now than they have ever been. Use them. When your local NWS office issues a watch, warning or advisory over the next few months, take it seriously. What does El Niño actually do to summer weather across the United States? The mechanism is the subtropical jet stream. During El Niño, the warm Pacific waters shift eastward towards South America. That warming reorganizes the tropical circulation. Specifically, the Walker circulation over the tropical Pacific weakens or reverses. That reorganization extends upward and northward into the mid-latitude atmosphere, enhancing the subtropical jet stream across the southern United States. A stronger subtropical jet means a more reliable moisture pipeline from the Gulf into the south and southeast. It means more storm activity in Texas, Louisiana, Mississippi, Alabama, and Florida during summer. It means the boundary between that active southern moisture regime and the cooler northern air mass is particularly sharp and energetic. The zone where that boundary sits, the Tennessee Valley, the Ohio Valley, the Central Appalachians, becomes one of the most active severe weather zones in the country during a strong El Niño summer. This is one of the strongest El Niño development signals I have seen emerge in June in many years of tracking these patterns. The pace of the sea surface temperature warming, the consistency of agreement across multiple modelling centres, and the supporting atmospheric indicators, including the measurable weakening of the Walker circulation, are all pointing in the same direction. NOAA has already announced a prediction of below-normal Atlantic hurricane season for 2026. That prediction is tied directly to El Niño. Strong El Niño events produce elevated wind shear over the tropical Atlantic. That shear prevents tropical systems from organising. The historical record is unambiguous. Strong El Niño years suppress Atlantic hurricane activity significantly. Below normal does not mean zero. It does not mean the Gulf and the East Coast are safe from any hurricane. One well-organised, well-placed storm can cause catastrophic damage regardless of how quiet the rest of the season is. But the overall risk profile for the Atlantic basin is lower under strong El Niño conditions. As of today, July 3rd, the National Hurricane Center has no organised tropical systems threatening the United States within the next 7 days. The shear over the tropical Atlantic and the Western Caribbean remains too high for meaningful development. What the models have been hinting at in the 10 to 14-day range is a period where the shear over the Gulf may relax. Both the Euro and the GFS have shown disturbances trying to organise in that time frame. I am not calling a Gulf hurricane at this range. The Gulf water temperatures are significantly above normal. The sea surface temperature anomalies across the Gulf are running well above the long-term mean, and any disturbance that enters that warm water environment during a window of reduced shear has exceptional thermodynamic energy available. We watch it. We stay data-driven. I will update you the moment the signal becomes clearer. Now, the West. AccuWeather's long-range team, updating their forecast through Thursday and Friday of this week, is projecting a new heat dome building between the Rockies and the Pacific coast next week. Denver is looking at the upper 90s to near 100 degrees Fahrenheit by next weekend. Possibly the low 100s the following week. Salt Lake City is projected to run mid-90s to near 100 next week, then likely low 100s the following week. Las Vegas and Phoenix have already set early season heat records this year. The setup now is for those records to be challenged again. AccuWeather meteorologist Brandon Buckingham flagged a specific concern about air quality that I want to highlight. A temperature inversion that develops beneath the new western heat dome will create light winds and may trap wildfire smoke over the interior west, resulting in a substantially broad area of poor visibility and reduced air quality. If you are in Utah, Nevada, Idaho, Montana, or the mountain communities of Colorado and Wyoming, this is not just a heat story. It is an air quality story. People with respiratory conditions should plan for days when outdoor activity needs to be limited. The North American monsoon is also about to become a factor. AccuWeather's long-range team expects the monsoon to become active toward the middle of July. The monsoon is the annual seasonal wind shift in the desert southwest, winds that normally blow from the west shift southward, pulling humid air northward from Mexico. This triggers the thunderstorm season in Arizona, New Mexico, and portions of southern Utah and Colorado. But in the first phase, before the humidity fully establishes itself, monsoon convection can produce dry lightning, storms high enough in the atmosphere that precipitation evaporates before reaching the ground. Dry lightning striking dry vegetation in extreme heat is a primary wildfire ignition mechanism. The initial phase of the monsoon, typically in early to mid-July, is when Arizona, New Mexico, and southern Nevada face their highest lightning ignition wildfire risk of the season. As the monsoon deepens and humidity rises through late July and into August, the dry lightning risk shifts northward, while rainfall increases in the core monsoon zone. New Mexico, southern Colorado, parts of Utah and Nevada then begin to see their best rainfall of the summer season. The monsoon is ultimately beneficial for those regions. It ends the dry fire season and recharges soil moisture. But the transition period, the first 2 to 3 weeks of monsoon onset, is the most dangerous from a wildfire perspective. The interaction between the new western heat dome, the monsoon onset, and the active storm track across the northern tier creates a summer pattern that I want you to understand as an interconnected system. The ridge in the west determines where the trough sits in the north. The monsoon moisture feeds the southern jet. El Nino is the engine underneath all of it. These are not separate regional weather stories. They are different expressions of the same atmospheric reorganization happening across North America simultaneously. And here is a piece of this story that almost no mainstream coverage is touching. The United States is not the only place experiencing this pattern. Severe-weather.eu reported this week that Europe may be heading toward a second major heat dome in early July 2026. A new high-pressure ridge may build over Western and Central Europe between July 7th and July 10th, potentially peaking between July 9th and July 14th. Spain, Portugal, France, Germany, Benelux, southern England, northern Italy, and parts of Central Europe are in the highest risk zone. Peak temperatures of 38 to 41 degrees Celsius, that is roughly 100 to 106 Fahrenheit, are possible in central and western Germany and neighbouring countries. The same omega block dynamics driving the US heat dome are simultaneously stalling a ridge over Europe. 2 continents, 1 week, 1 underlying mechanism. This is what a super El Niño looks like at the global scale. The mid-latitude atmospheric circulation is reorganizing on a planetary level, not just over North America. Let me bring this back to specific communities and specific days, because at the end of this forecast what matters is whether you are ready for what is actually coming to your location. For Sioux Falls, Aberdeen, and Rapid City in South Dakota, today and Saturday carry the highest tornado risk in this current weather event. Afternoon discrete supercells are possible in both of those windows. The Storm Prediction Center has been watching this area closely. Have your storm shelter plan ready and know where you're going if a tornado warning is issued in your county. For communities in Nebraska, Omaha, Lincoln, Grand Island, Kearney, the severe weather threat runs from today through Saturday. Friday's risk zone from the SPC includes central Nebraska specifically, with the zone from the southeastern Dakotas through central Iowa and northwestern Missouri as the concentrated threat area for Saturday. Hail sizes on Friday and Saturday could reach baseball or larger in isolated supercells. The flooding risk is secondary but real for the western Chicago suburbs and communities that already received 3 to 4 inches of rain this week. Your drainage systems are stressed. Your streams are running high. The next rounds of storms, tonight, Friday and Saturday, carry a meaningful flash flood risk. Please do not attempt to drive through flooded roads. Cars can be swept away by moving water that appears shallow. Turn around, do not drown. For Pittsburgh, Monday is your storm day. Not today, not Saturday. Monday. The AccuWeather local storm max for wind in Monday's event is 80 miles per hour. The WPC has issued a slight risk of excessive rainfall for the mid-Atlantic on Monday, specifically targeting your region and extending eastward to the Jersey Shore and northward into upstate New York. Plan your outdoor activities accordingly. For the southeast, Atlanta, Charlotte, Columbia, Raleigh, Richmond. The heat is not done with you. The WPC is projecting heat index values of 105 to 110 degrees returning to your region during the week of July 7th. Air conditioning access, hydration, and outdoor work timing are going to matter a lot next week. If you have workers or family members who spend extended time outdoors, make sure they are monitoring the heat index and taking breaks during peak heating hours. For Salt Lake City, Denver, Las Vegas, the new heat dome is building in your direction. Salt Lake City is projected to reach the low 100s the week of July 14th. Denver approaches 100 degrees by next weekend. Air quality concerns from wildfire smoke trapped under the inversion will compound the heat risk. Monitor your local air quality index in addition to the temperature forecast. I am going to leave you with the sequence of numbers that defines the entire summer story. Positive 1.7 degrees Celsius, where the Ninyo 3.4 anomaly stood on June 17th. Climbing. 13 out of 24, the number of IRI model runs already projecting strong or very strong El Nino by fall. 200 million. Americans under extreme heat alerts as of today, July 3rd. 9 inches. The rainfall total northwest of Des Moines in 24 hours this week, before the major collapse storms have even arrived. 85 miles per hour, the AccuWeather local storm max wind gust for the active storm zone, extending from northern Mississippi all the way to Vermont and New Hampshire. 105 to 110 degrees, the projected heat index values returning to the southeast during the week of July 7th. These numbers do not tell you everything, no forecast does, but they tell you enough to act. Shelter plans, emergency kits, checking on neighbours, flash flood awareness for the weekend, heat awareness for next week, and for those of you in the Midwest tonight and Friday. Please be inside before these storms arrive. If today's forecast gave you something useful, a like and a subscription helps this channel reach more people who need this information. Tomorrow I will have a specific deep dive on Monday's Pittsburgh to Virginia Beach severe weather setup, as the model data comes into better focus. I will also be updating the tropical picture as we cross into the 10-day window, where some of the models are starting to show activity in the Gulf. That is a story that could develop quickly, and I do not want you to miss it when it does. Stay with the data, stay weather aware, and I will see you tomorrow. Let me now go much deeper on the mechanism behind what you're seeing today, because the science here is genuinely fascinating, and understanding it gives you a different relationship with severe weather. It stops feeling random and starts feeling predictable. That shift from confusion to understanding is what this channel is about. The heat dome that has been sitting over the central and eastern United States this week is technically classified as an upper-level ridge of high pressure. High pressure in the upper atmosphere corresponds to areas where air is sinking toward the surface. Sinking air compresses as it descends, compressed air heats up. This is basic atmospheric thermodynamics, the same reason air coming out of a bicycle pump feels warm. The sinking air acts as a lid on the atmosphere below it. Clouds cannot form effectively under that lid. Rain cannot develop. The sun heats the surface unimpeded by any cloud cover. Surface temperatures rise well beyond what they would under normal summer conditions. The humidity makes it dramatically worse. The Gulf Basin has been incredibly warm this summer. Evaporation from the Gulf surface is producing enormous amounts of water vapor, and that vapor gets transported northward on southerly surface winds. When that humid air mass sits under the heat dome lid, no rain to wring out the moisture, no cloud cover to block the sun, the surface simply heats and heats and heats. Dew points in the low 70s are what meteorologists call oppressive. At a dew point of 72 degrees and an air temperature of 94 degrees, the heat index is 115. That is the apparent temperature your body is trying to regulate against. Your cooling mechanism, sweating, becomes less efficient in humid conditions because the air is already saturated with moisture and evaporation slows. That is why high humidity at high temperatures can be genuinely life-threatening in ways that dry heat at the same temperature is not. The National Weather Service issues excessive heat warnings when heat index values are expected to reach 105 degrees or higher for 2 or more days, or when overnight temperatures are not expected to fall below 75 degrees for at least one night. The East has been under those warnings for multiple consecutive days. That is not a normal summer pattern. That is an exceptional atmospheric event. Now, the breakdown. When the omega block finally begins to erode, the first thing that happens is the shortwave troughs on the flanks of the ridge gain strength. A shortwave trough is essentially a small ripple of lower pressure and cooler air in the middle and upper atmosphere. As the ridge weakens slightly from north to south, these shortwave features can punch further south and east than they normally would. Each shortwave passage provides lifting, upward atmospheric motion that triggers storm development. The problem is that under a weakening heat dome, you still have all that unstable, moisture-rich air at the surface. You just do not have the cap suppressing it anymore. So when a shortwave provides that lifting, the atmosphere responds explosively. This is why heat dome collapse events are associated with the most violent thunderstorm outbreaks. You have been storing atmospheric energy for days, and then the cap breaks. The SPC Day 4 through 8 outlook, issued Thursday morning, specifically noted that southwesterly mid-level winds will persist longer in the Intermountain region, as the western ridge amplifies less than previous model cycles suggested. This is important because southwesterly mid-level flow is the classic setup for supercell thunderstorms. Supercell thunderstorms, the kind that produce tornadoes, large hail and destructive winds, develop best when the wind direction changes with height in the atmosphere, creating a spinning motion that a rising updraft can then tilt and organize. Southwesterly flow at the middle levels, with southerly flow at the surface, creates exactly that environment. That is why the northern plains and upper Midwest get the tornado and severe hail risk during this period, while areas further east get primarily the damaging wind and flooding risk. The atmosphere in the plains has the necessary wind shear for supercell development. Further east, that shear is weaker, but the instability is even higher, which produces fast-moving bowing segments with their characteristic damaging straight-line winds. Let me talk specifically about what happened last Tuesday and Wednesday this week, the June 10th, 2026 regional tornado outbreak, because that event is directly relevant to understanding the atmosphere you're dealing with right now. The NWS Chicago event. Summaries page documents the June 11th, 2026 event as a regional tornado outbreak, including 2 EF2 and 2 EF3 tornadoes in the local area. The June 10th event is documented as a derecho producing widespread wind damage across northern Illinois. Those events happened less than 3 weeks ago. The atmosphere in the Midwest and Great Lakes is still in an active, highly energized pattern. The same El Niño-enhanced subtropical jet, the same pattern of repeated shortwave troughs moving through, the same deep moisture from the Gulf, all of that is still in place. The heat dome added an unprecedented layer of instability on top of an already active pattern. Fox Weather's reporting on the June severe weather sequence documented a corridor stretching from Iowa through Illinois and into Indiana bearing the brunt of multiple outbreaks, with widespread reports of wind damage, large hail and tornadoes. Communities in Streator, Illinois reported extensive tornado damage. Lake County, Indiana saw a confirmed tornado near Interstate 65 north of the Kankakee River. The June Midwest outbreak sequence was described by Fox Weather meteorologists as carrying a rare, violent synergy, with individual storms projected to move at up to 60 miles per hour, fast enough to impact communities before warning systems could reach everyone. I'm telling you this history not to alarm you, but to contextualize what the atmosphere is capable of right now. When the SPC places a slight risk over the northern plains or the Midwest, they are doing so against the backdrop of an atmosphere that has already produced EF3 tornadoes this month. Now let me go deeper on the flooding risk, because I think this is the hazard that is most likely to catch people off guard over the next 72 hours. The WPC issues a product called the Excessive Rainfall Outlook. It is separate from the Severe Weather Outlook. It focuses specifically on the risk of rainfall amounts that could cause flash flooding. The WPC uses 3 risk categories in their near-term outlooks: marginal, slight, and enhanced. Above that, they have moderate and high risk. As of this morning, the WPC has placed slight risks across multiple regions for the coming days. Slight risk in WPC's excessive rainfall framework means that at least 10% of the forecast area could receive rainfall totals that lead to flash flooding. 10% sounds small, but when your risk area covers 8 or 10 states, 10% of that zone is a lot of communities. The 9 inches northwest of Des Moines, let me give you a sense of what that represents in historical terms. The climatological monthly average rainfall for Des Moines in July is approximately 4 inches for the entire month. 9 inches in 24 hours is more than double the monthly average in a single day. That kind of event does not fit within the design parameters of most urban stormwater systems, most rural drainage channels, or most bridge culverts. When you receive that much rainfall that fast, every low point collects water, every small stream becomes a raging creek, and every underpass becomes a trap. The 4 inches that fell in suburbs west of Chicago is less extreme but follows the same pattern. The ground was already moist from previous storms, and 4 inches over several hours was enough to produce significant localized flooding. AccuWeather stated this morning, as I have mentioned, that the local storm max rainfall for the coming event is 6 inches. I want to connect that number to the communities northwest of Des Moines specifically. Those communities received 9 inches earlier this week. Their soil moisture is at or near saturation. Their drainage channels are running. If another 6-inch event tracks over the same area over the next several days, the cumulative impact would be devastating. Flash flooding that was dangerous the first time would be catastrophic the second time. The WPC's stormwater runoff models take soil moisture into account. When they issue slight risks in areas that have already received significant rainfall, the threshold for flash flooding is lower than it would be for dry soil. The atmosphere does not care that communities already flooded once this week. I have been covering severe weather and atmospheric patterns for years. I have watched communities get hit twice in the same week, with the second event being worse than the first because the ground was already saturated. Please take the flood risk seriously even if you went through last week's event without major problems. The margin for safety is smaller now than it was before last week's rainfall. Now let me talk about something I find genuinely important: the difference between watching weather and understanding weather. Most of the coverage you're seeing about this heat dome focuses on temperature records. New York is this hot. Philadelphia is that hot. These are important and they are true, but temperature is the symptom, not the cause. The cause is atmospheric blocking. Understanding blocking patterns is what allows you to say 6 or 7 days in advance that a heat event is coming, and then to say, a few days later, that the collapse will produce violent storms. Meteorologists at NOAA's Weather Prediction Center and the Storm Prediction Center make those kinds of predictions every day, and they do it with tools that have become remarkably accurate over the past 2 decades. The Global Weather Model Guidance, the GFS from NOAA, the ECMWF from the European Centre, the NAM and the HREF for shorter-range severe weather, has improved dramatically. 5-day temperature forecasts today are as accurate as 2-day forecasts were 30 years ago. 7-day severe weather outlooks from the SPC, which would have been essentially impossible in the 1980s, are now genuinely useful planning tools. That capability matters most to you right now because the watches and warnings issued over the coming days are backed by better models and better science than any previous generation of forecasters had access to. When the SPC upgrades a risk area from marginal to slight, or when the WPC places a slight risk of excessive rainfall on a specific day, that is not guesswork. It is the output of physically based atmospheric models run on some of the most powerful computers in the world, calibrated against decades of observational data. Take those outlooks seriously. Let me talk about what you should actually do with this information today and over the coming days. Today, July 3rd, if you are in the northern plains or upper Midwest, have your storm shelter plan ready before 3 in the afternoon. Know the lowest level of your structure. Know the location of your nearest public storm shelter if you do not have a basement. Have your phones charged. Download your local NWS app or the Weather Channel app and enable severe weather alerts. If you are outdoors tonight, fireworks, camping, outdoor events, know what you will do if a severe thunderstorm warning is issued for your county. Have a location identified before the show starts. Friday, July 4th. Monitor the forecast throughout the morning. The storm situation on Friday is broad. It covers 18 states or more in terms of some level of storm risk. Your specific risk depends heavily on your location within that zone. The SPC's Day 2 outlook, which updates through the day, will refine the picture. Pay attention to which risk category your county falls in on Friday morning. If your county is in a slight risk on Friday morning, review the timing of when storms are most likely and plan your outdoor activities around that window. The most dangerous times will be the afternoon and early evening hours, when heating of the day is maximised and the shortwave trigger is moving through. Saturday, July 5th. Watch your morning outlook carefully. Saturday has the potential for a focused, organised, severe weather outbreak in the central Nebraska through central Iowa through northwestern Missouri zone. If you are anywhere in that region, and the SPC places a slight or enhanced risk for Saturday, please be indoors during the peak hours. The atmosphere on Saturday is going to be extremely unstable. Sunday, July 6th. The pattern is uncertain. Stay close to your local NWS office's forecast discussion. If you are in the northeast or mid-Atlantic, watch for updates on whether the storm system becomes more organised than models currently show. Monday, July 7th. If you are in western Pennsylvania, Maryland, northern Delaware, New Jersey, or northern Virginia, this is your primary storm day. Have your plans flexible. The AccuWeather local storm max for wind on Monday in that zone is 80 miles per hour. The WPC excessive rainfall slight risk is formally in place for your region. Monday is not the day to set up outdoor events without a clear shelter plan. The week of July 7th through the 14th. If you are in the southeast, Georgia, Alabama, Mississippi, Louisiana, the Carolinas, prepare for the heat to return with full intensity. The WPC's extended forecast projects heat index values of 105 to 110 degrees across your region for multiple consecutive days during that week. That is on top of heat you have already been experiencing. Cooling centres, hydration stations, and welfare checks on vulnerable populations need to be planned and activated before that heat arrives, not after. Here is a question I genuinely want you to think about and answer in the comments. Has your community set up any kind of formal cooling centre program or heat emergency response plan this summer? I am curious to hear from people across different regions about what local preparedness looks like on the ground. The more I understand about how communities are actually responding to events like this, the more useful I can make this forecast coverage. Let me spend some time now on the long-range picture, not just the next 14 days but the rest of the summer and into fall, because the El Nino signal is so strong right now that there are meaningful things I can tell you about the summer and early fall weather pattern with a reasonable degree of confidence. The NOAA CPC's current 6 to 10 day outlook, valid through the middle of July, shows above normal temperature probabilities for the south, southeast, and parts of the southwest. Below normal temperature probabilities are essentially absent from the contiguous United States. That means there is no significant cold air source available to drive deep relief across the country in the near term. What you are getting in the east as the heat dome weakens is relatively cooler air from Canada, but Canadian air in July is not cold air. It is seasonable air, maybe slightly below normal. The difference between a heat index of 110 and a temperature of 84 with lower humidity is enormous from a comfort and safety standpoint. But it is not a pattern change. It is a brief break. The CPC 8 to 14 day outlook shifts back toward above normal temperature probabilities over a large portion of the central and eastern country. This is entirely consistent with what El Nino does to summer atmospheric patterns. The heat does not stay on vacation. The southeast heat rebuilds. The plains stay warm. The northern tier gets periodic relief from Canadian intrusions that then trigger the active storm episodes. For precipitation in the 8 to 14 day period, the CPC shows above normal probabilities for the central part of the country, the Midwest, the Central Plains, parts of the Southeast. Below normal precipitation is projected for the Pacific Northwest and portions of the Northern Rockies. This is again consistent with El Niño's typical summer pattern. An active southern jet keeps moisture streaming into the central country, while the west is relatively dry. Severe-weather.eu published their Super El Nino Impact Assessment this week, and I want to share some of the key points with appropriate caveats about long-range uncertainty. Their analysis found that previous Super El Nino years, 1997 through 98, 2015 through 2016, were characterized by enhanced jet stream activity over the southern United States in summer and fall, leading to above-normal severe weather frequency in the Gulf states and the Tennessee Valley. The current development, if it verifies at the strength that most models are projecting, would fall in the same or higher category as those previous strong events. What that means in practical terms, The tornado season for the south is likely to remain active later into the summer and fall than normal. Normally, the peak tornado risk in the south is spring, March through May. In strong El Niño years, that active period extends into the summer and produces above normal severe weather activity in September and October as well. If you are in Mississippi, Alabama, Tennessee, or Louisiana, your severe weather awareness cannot go away after the 4th of July weekend. The pattern that is setting up suggests continued activity well into the fall. The Colorado State University Tropical Weather Group, which publishes some of the most rigorous Atlantic hurricane season forecasts in the academic community, issued a forecast this season reflecting the El Niño influence. Their prediction is for below normal Atlantic hurricane activity. I track CSU's forecast closely because their methodology has one of the strongest verification records in seasonal hurricane prediction. Below normal, not zero, not safe. Below normal, one storm in the right place at the right time. The Gulf water temperatures are a wild card in this picture. Even with El Niño driving sheer over the tropical Atlantic, the Gulf itself has extremely warm sea surface temperatures. If a system develops in the Western Caribbean or near the Yucatan during a window of reduced shear, it would have exceptional energy available to it. The Gulf is a thermodynamic powerhouse right now. I watch the Gulf tracking as closely as I watch the shear tracking. When those two factors align, low shear, warm Gulf, that is when the risk becomes real. The Eastern Pacific, on the other hand, is extremely active under El Niño. The warmer Pacific waters and reduced shear on that side are producing an active Eastern Pacific hurricane season. Communities on the Pacific coast of Mexico, Central America, and in the Baja Peninsula need to be on elevated alert throughout the summer. El Niño historically produces above normal Eastern Pacific seasons while suppressing Atlantic activity. We are seeing exactly that pattern this year. One more piece of the long-range picture that I want to cover: the North American monsoon and its interaction with the Western heat dome. The monsoon is often described as a seasonal wind shift, but it is actually a full reorganization of the summer weather pattern across the desert southwest. It begins when the subtropical high, the same type of high-pressure system that becomes a heat dome further north, shifts northward enough to allow southerly moisture flow from the Gulf of California and the Pacific coast of Mexico into Arizona, New Mexico, and adjacent areas. When that shift happens, afternoon thunderstorm development becomes nearly daily across the region. AccuWeather's meteorologist Brandon Buckingham, in their long-range assessment this week, specifically described the initial monsoon as likely to produce dry lightning and hayboob dust storms before the humidity builds enough to produce significant rainfall. A hayboob is a massive dust storm driven by cold outflow from collapsing thunderstorm cells. They can be spectacular visually and extraordinarily dangerous physically. Wall of dust events that reduce visibility to near zero in seconds. Phoenix has experienced multiple major haboobs in the past decade during monsoon onset. If the monsoon onset this year is early and aggressive, which El Niño conditions could support, the haboob and dry lightning season in Arizona and New Mexico could be intense in the 2nd and 3rd weeks of July. For communities in Tucson, Phoenix, Flagstaff, Albuquerque, and Santa Fe, watch the monsoon onset signal carefully. The transition from dry season to monsoon season in your region is usually marked by a shift in dew points from the single digits and teens into the 40s and 50s. When your dew points start rising consistently, the monsoon is arriving. Before they rise fully, you're in the dry lightning and dust storm window. That is when driving in rural areas is most hazardous, when fire lookout stations are most critical, and when the combination of heat, smoke, and dust can create genuinely dangerous conditions. I want to close the forecast today by connecting all of these threads into a single coherent picture. You are living through one of the most significant atmospheric events of the decade, not just a bad heat wave, but the early expression of what may be a historically strong El Niño. The NOAA-CPC's official advisory, the IRI Columbia Model Ensemble, the ECMWF long-range output, and the independent analysis from severe-weather.eu all point in the same direction. El Niño is here, it is strengthening, and its peak is still months away. In the near term, today through Monday, the immediate risk is severe weather and flooding across the northern Midwest, the Central Plains, and the Mid-Atlantic. In the medium term, July 7th through the 14th, the southeast faces a dangerous heat rebound, while the northern tier continues its active storm pattern. In the longer term, The rest of July, August, and into fall, El Niño maintains an active pattern across the south and southeast, suppresses Atlantic hurricane activity, but leaves the Gulf as a thermodynamic wildcard, and drives the western heat dome that challenges records in Utah, Nevada, and Colorado. This is one of the strongest summer atmospheric patterns I have seen in years, not just in terms of the immediate heat event, though that has been extraordinary, but in terms of the persistence and breadth of the atmospheric reorganization happening underneath it. Positive 1.7 degrees Celsius and climbing. 13 out of 24 models projecting strong to very strong by fall. An active severe weather pattern across most of the country that shows no sign of fundamental relaxation through the end of July. Be prepared, check the forecasts, check on your neighbours, know your shelter plan, know your flood risk, and stay with this channel because I am going to be updating you every single day as this pattern evolves. Please like today's video if it gave you something you can use. Hit subscribe so you're notified when tomorrow's update goes up. I will have the latest model data on Monday's storm setup, the western heat dome buildup, and any early signals from the tropical watch window. The next 72 hours have several important forecast decision points, and I want to make sure you're informed for all of them. I will see you tomorrow. There is one more thing I want to add before we close today, and it falls under the category of what I call pattern context. The kind of background information that makes any individual forecast more meaningful. The summer of 2026 is going to be discussed in meteorological circles for a long time. We are going to look back at this period and note when the Super El Niño signal first became unambiguous in the models. We are going to note when the atmospheric bridge connecting the Pacific warming to the North American circulation first became measurably active. We are going to note the timing of the first major heat siege over the central and eastern United States. All of those things are happening right now in real time during this 4th of July holiday weekend. The NOAA CFS V2 model, NOAA's own coupled climate forecast system, has been showing a very similar trajectory to the ECMWF for weeks now. Both are projecting a peak El Niño anomaly that rivals or exceeds the strongest events in modern records. The BOM, the Australian Bureau of Meteorology, reached the same conclusion from the Southern Hemisphere perspective. 3 major modelling centres on 3 continents are converging on the same signal. When that kind of cross-system agreement exists, the confidence in the broad direction of the pattern increases substantially. What does that mean for you, practically, as you plan the rest of your summer? If you're in the southeast or south, Texas, Louisiana, Mississippi, Alabama, Georgia, Florida, the Carolinas, Tennessee, the next 2 to 3 months are likely to be hotter and stormier than a typical summer. Plan your outdoor events with weather awareness built in. Know your heat thresholds. Keep your emergency kit current. If you have family members who are elderly or have health conditions exacerbated by heat, make sure you have cooling plans in place and that those plans do not depend on a single point of failure, like a single air conditioner that could break during a sustained heat event. If you are in the northern Midwest, Minnesota, Wisconsin, Michigan, Iowa, Indiana, Illinois, the summer looks like an active severe weather pattern through July and likely into August. Tornado and damaging wind events have been hitting this region with above normal frequency already in 2026, and the atmospheric conditions that drove that activity are not going away. Know your county's storm warning systems. Know whether you receive wireless emergency alerts on your phone. If you do not, check your phone settings now, not during a tornado warning. If you're in the West, particularly Utah, Nevada, Arizona, Colorado, New Mexico, prepare for the heat dome that is building next week and for the monsoon onset that follows. Wildfire smoke will be a quality of life issue through mid-July. Air quality index apps are as important as weather apps during this period. If you have respiratory conditions, asthma, COPD, heart conditions that are affected by air quality, have a plan for the days when the air quality index spikes above 150. If you are along the Gulf Coast, from Brownsville through Mobile and up through Tampa, the below-normal Atlantic hurricane season outlook from NOAA is reassuring, but it is not a guarantee. The Gulf water temperatures are exceptionally warm. The 6-month hurricane season still has 4 months to go. Keep your hurricane preparedness kit updated. Know your evacuation routes. Monitor the NHC every day during any period when the models are hinting at Gulf activity, and I will let you know when those signals strengthen. If you're in the Northeast, New York, New Jersey, Pennsylvania, Massachusetts, Connecticut, New Hampshire, Vermont, Maine, you're going to get relief from this heat in the next few days, but the relief comes with a storm price tag. Flash flooding on Monday is real. Stay aware of that risk throughout the weekend. After Monday, a more comfortable pattern is likely for a few days. But the SPC's extended outlooks project the storm track remaining active across the northeast through much of the summer, consistent with the El Niño pattern. The number that I want to end on is not a temperature record or a wind speed. It is this, positive 1.7 degrees Celsius in mid-June. That is where El Niño stood when IRI Columbia took their last formal measurement. It is climbing. Multiple modelling centres say it will reach positive 2 or higher by fall, qualifying as a strong event. And the ECMWF and NOAA's own CFS V2 are showing runs that approach positive 3 or beyond. If those projections verify, the second half of 2026 and the winter of 2026 through 2027 are going to be dominated by El Niño influences in ways that reach every corner of the United States and well beyond. I cover this channel because I genuinely believe that an informed community weathers these events better than an uninformed one. Every person who understands the difference between a marginal and a slight risk, or who knows what ring-of-fire convection means, or who understands why overnight low temperatures matter more than daytime highs during heat waves, that person is better positioned to protect themselves and the people around them. That is why I do this work. And that is why the subscribe button matters. Not for the numbers, but because people who are subscribed get the next update the moment it goes live. In a rapidly evolving pattern like this one, timing matters. Stay with the data, stay weather aware, and I will see you tomorrow with the latest on Monday's storm setup and everything else that is developing across this remarkable atmospheric pattern.